After watching this video, you should be able to number 1. Define electrochemistry and its applications in our everyday lives. Number 2. Identify the similarities and differences of the two types of electrochemical cells. Number 3. Tell whether an electrode is classified as an anode or a cathode. And lastly, discuss how a galvanic cell works.
Electrochemistry constitutes one of the most important interfaces between chemistry and everyday life. Every time you start your car, turn on your calculator, use your smartphone, or listen to radio at the beach, you are depending on electrochemical reactions. Our society sometimes seems to run almost entirely on batteries. Certainly, the advent of small, dependable batteries along with silicon chip technology has made possible the tiny calculators, portable audio players, and cell phones that we take for granted. Electrochemistry is important in other less obvious ways. For example, the corrosion of iron, which has tremendous economic implications, is an electrochemical process. In addition, many important industrial materials such as aluminum, chlorine, and sodium hydroxide are prepared by electrolytic processes. In analytical chemistry, electrochemical techniques use electrodes that are specific for a given molecule or ion, such as H+, F-, Cl-, and many others. These increasingly important methods are used to analyze for trace pollutants in natural waters or for the tiny quantities of chemicals in human blood that may signal the development of a specific disease. Electrochemistry is best defined as the study of the interchange of chemical and electrical energy. It is primarily concerned with two processes that involve oxidation-reduction reactions, or the generation of an electric current from a spontaneous chemical reaction, and the opposite process, the use of current to produce chemical change.
There are two types of electrochemical cells, namely the galvanic or voltaic cell and the electrolytic cell. A galvanic cell, which is located on the left, transforms the energy released by a spontaneous redox reaction into electrical energy that can be used to perform work. The oxidative and reductive half reactions usually occur in separate compartments that are connected by an external electrical circuit. In addition, a second connection that allows ions to flow between the compartments, shown here as a vertical dashed line to represent a porous barrier, is necessary to maintain electrical neutrality. The potential difference between the electrodes, which is in voltage, causes electrons to flow from the reductant to the oxidant through the external circuit, generating an electric current. In an electrolytic cell, which is located on the right, an external source of electrical energy is used to generate a potential difference between the electrodes that forces electrons to flow, driving an unspontaneous redox reaction. Only a single compartment is employed in most applications. In both kinds of electrochemical cells, the anode is the electrode at which the oxidation half reaction occurs, and the cathode is the electrode at which the reduction half reaction occurs. Voltaic cell, also called a galvanic cell, uses a spontaneous redox reaction delta G is less than 0 to generate electrical energy. In the cell reaction, sum of the difference in free energy between higher energy reactants and lower energy products is converted into electrical energy, which operates the load, flashlight, MP3 player, car starter motor, and so forth. Thus, the system does work on the surroundings. All batteries contain voltaic cells. An electrolytic cell uses electrical energy to drive a non-spontaneous redox reaction. Delta G is greater than 0. In the cell reaction, an external power source supplies free energy to convert lower energy reactants into higher energy products. Thus, the surroundings do work on the system. Electroplating and the recovery of metals from ores utilize electrolytic cells. An electrochemical cell is a device that produces an electric current from energy released by a spontaneous redox reaction. This kind of cell includes the galvanic or voltaic cell, named after Luigi Galvani and Alessandro Volta. The oxidation half reaction occurs at the anode. Electrons lost by the substance being oxidized, which is the reducing agent, leave the oxidation half cell at the anode. The reduction half reaction occurs at the cathode. Electrons gained by the substance being reduced, which is the oxidation agent, enter the reduction half cell at the cathode.
To avoid getting confused over and over again, we can use these mnemonics. The red cat is for the reduction process which occurs at the cathode, while an ox is for the oxidation occurring at the anode.
Electrons are produced at the zinc rod, according to the oxidation half reaction shown. Because it is oxidized, the zinc rod is the anode, an ox. The electrons leave the zinc anode and pass through the wire to the copper rod, thus creating an electric current. The voltmeter measures the voltage. Electron enters the copper rod and interact with copper ions in solution. There the following reductions half reaction occurs. Because copper ions are reduced at the copper rod, the copper rod is the cathode, red cat. The salt bridge connects the two containers. It provides a path for a flow of ions between the two beakers in order to maintain neutrality in the solutions. The two half reactions can be summed to show the overall reactions.